All right, so we're moving on to lesson 2. This one should be a lot quicker. There's one kind of tricky topic at the end, but the rest of it's all really straightforward. So before we do anything else, I want us to kind of do a warm-up. And so this video is going to pause. Number 1, I want you to try to do this one without a calculator. Try to do that one by hand. So leave your answer, as a radical, like square root of 40 or square root of 60, whatever it is. But try to do this one by hand. And then numbers 2 and 3, you can use a calculator for. All right. So you're going to get asked to answer your questions, and then we'll go over them afterwards. So for number 1, I'm going to just do this with the formula x1, y1, x2, y2. If you wanted to graph this on a, you could have graphed this as well, and sometimes that's easier for students, right? Right, to graph it and then do the whole like a, b, and c, and do a squared plus b squared equals c squared. If you did that, that's awesome. But I'm going to just show it with the formula. So the formula is x2 minus x1, negative 4 minus 2 is negative 6, plus y2 minus y1, 1 minus negative 3 is 4. This becomes the square root of 36 plus 16, which is the square root of 52. I'm just going to leave my answer like that. You could type it into a calculator, get a decimal, but I'm going to leave that as my answer. That's kind of what I asked us to do. Okay, for numbers 2 and 3, same process, but this time we can use a calculator. Now, x2 minus x1, when you do 3.25, that keeps happening, 3.25 minus negative 4.75, they add, and you actually end up with 8. And then 5.5 minus negative 8.5, you end up with 14. And I'm going to do this one by hand, actually. 8 squared is 64, and 14 squared is 196. And you end up with the square root of 260. And then you can type that into a calculator. And you end up with, I believe it's 16.1245. If I got that wrong, just correct it. But I think that was the answer. And then for number 3, again, I said you could use a calculator. So 10 minus 9 fourths. Now I'm going to kind of write these as decimals. So this is 1.25. And this is 2.25. So 10 minus 2.25, we should end up with 7.75 squared. And then plus 0 minus, we'll end up with negative 1.25 squared. If you left those as fractions, that's fine too. And then you'll just type those into a calculator. So 7.75 squared, we end up with 61.625 when we add up those two, and then 7.85. I think I asked you to round your answers to 1 decimal on these, so you would have just reported a 16.1 and 7.9. All right, moving on. This, again, hopefully this is really a lot of review for you. So this is something you really should have been doing since elementary school. So the area of a shape is the inside space, right? So like the area of a triangle or a rectangle would be the space inside of that triangle or rectangle or whatever shape you have, right? So kind of that highlighted area here. Whereas the perimeter is the distance around a shape. So if you took like a string, if you kind of imagined having a string, oh my goodness. One second. Having some major technical difficulties here. Okay, so if you took a string, you kind of imagine having a string and just kind of laying a string down around a shape. And then you just kind of untied that string and just laid it out flat. You're going to make a really long distance. That distance is the perimeter, right? That distance of, how long your string was, that would be your perimeter. Okay, if you think of a tile floor, right, like if you had to paint the tile, that would be the area. But if you laid a string around it, that would be the perimeter. So that's our difference. The same thing here, perimeter would be that distance around a triangle, whereas area is this, blue distance within it. Okay, so for area, usually we're going to have a formula whenever we have area. Okay, and our units, if we do have units, they become units squared. And then perimeter is our distance around. You don't need a formula for this. You'll get weird formulas like, 2L plus 2W or whatever. I don't really ever want you to memorize any formula for a perimeter. It's just a waste of your time. Just add up all of the sides. That's the easiest way to do it. Okay? So for a rectangle, right, our formula for an area, you should be familiar with this, is base times height. Sometimes you'll see it if you're in engineering. I usually write it as width times height. And in some other math classes, you might see length times height or length times width. They're all the same thing, right? Your base is just one side, and your height is the side that makes the right angle with it. right? And so we just multiply them together, and that gives area. So for this example, right, the area would be, we call this the base, we'll call this the height, would be 8 centimeters times 4 centimeters. Now what happens when you multiply centimeters times centimeters is it becomes centimeters squared. All right, and then for the perimeter, we're just going to add up all the sides. So 8 centimeters plus 4 centimeters. Now plus this side, it's a rectangle. What do we know about rectangles? Opposite sides are the same. So that's 8 and that's 4, so plus another 8 and plus another 4. If you don't write the units within the step, that's fine. Just write them at the end. So 8 plus 4 is 12, plus another 8 is 20, plus another 4 is 24. And our units for perimeter just stay the same. They stay as centimeters. When we're adding, they don't become squared. They just remain the same. All right, for triangles, again, hopefully you're familiar with this. The main formula we're going to use is area 1/2 base times height. But you can see base times height over 2. Sometimes you'll see this like, in questions or in textbooks, they'll write it this way. This is the exact same thing. Remember we learned, very early on this semester that if I multiplied, times 1/2, that's the same as dividing by 2, right? So multiplying by 1/2 is the same as dividing by 2. So sometimes they'll write this as base times height divided by 2. Same thing, they just, move the 1/2 to become divided by 2. So there are kind of 3 cases. And, one case is very easy where we can see the base of a triangle is the bottom and the height is just inside. Okay? Here again, the base is the bottom. Now in this case, the height is outside. So we kind of have to just draw an imaginary line over and down. But we can still see that, the height here is vertical, the base is horizontal. The base is horizontal, the height is vertical. Whereas sometimes we get something funky where we don't have a horizontal or vertical, and so that's kind of a case 3, which is a little bit tricky. So we'll go through these. Case 1 and 2, super easy. So find the area and perimeter of triangle ABC. So for the area, what's our formula? 1/2 base times height. So we're going to do 1/2 times the base of this triangle is 1, 2, 3, 4, 5, 6. The height is 1, 2, 3, 4, 5, 6, 7, 8. So 1/2 times 6 times 8. Do it in any order. Half of 6 is 3. 3 times 8 is 24. You could have done 6 times 8 is 48. Divided by 2 is 24. You could even do 8 divided by 2 is 4 times 6 is 24. Math works that way, associative commutative properties. But for the perimeter is going to be a little bit trickier. Because for the perimeter, what do? We add up all of our sides. Well, we have 6 plus 8 plus we don't know what this side AC is. So we're going to have to do Pythagorean Theorem for that side. So, there's our right angle, that's C. So do A squared plus B squared equals C squared. That's 36 plus 48 equals C squared. 6 plus 8 is 14. 84 equals C squared. And we're going to take the square root of both sides. I messed that up. I don't know what I just did. Hopefully you are smarter than I am. 8 squared is not 48. 8 squared is 64. 36 plus 64 is 100. And then the square root of 100 is 10. So these numbers were very nice. So 6 plus 8 plus 10. And we get 24 as well. Now, if we needed units, we could say this is units squared, and this is just units. Right? On a coordinate plane, you just put units or units squared because this could be representing centimeters, inches, feet, we don't know. But we know these are in units squared and these are in units. So these are actually not the same. 24 units squared is not the same as 24 units. 24 units squared is kind of like a space. It's like as if I painted that inside. Whereas 24 units, it's a distance. It's the distance around. So even though the numbers are the same, they're actually really not the same thing. And this is a coincidence. In this case, both answers were 24. That's not always going to happen. Okay. So, and we'll see that with case 2. So on case 2, find the area of triangle ABC. So our area. So this is where we want to be very careful about what we're counting by. Okay. This is counting by each big box you can see is 1. So this is at 0, this is at 1, this is at 2. Right? Each big box is counting by 1. So this width here is a width of 2. And for my height, right? The height always makes a right angle with the base. So this base is 2. What I can do is I can just kind of extend this line down and across to make that right angle to get my height. So my height is 1, 2, 3, 4. Okay. So we have 1/2 times 2 times 4. Those cancel. And so my area would be 4 units squared. Now, I'm not really going to do the perimeter on this one, but if we had to do the perimeter, what would we do? We would do, a right triangle here and mark that as my C and do 1 squared. Actually, I guess I'll do it really quickly. 1 squared plus 4 squared equals C squared. Right, that's square root of 17 equals C squared. Let's just round this off. So we get 4.1231. And then we would need to do, so that's that C. Now we need to do it for this C. And just kind of extend it over and down. So this is 1, 2, 3. And then this is 1, 2, 3, 4. So do 3 squared plus 4 squared equals, I'll call this like C2. My second C squared, that's 16 plus 9. 9 plus 16, I wrote it backwards. 3 squared is 9 plus 4 squared is 16. That's 25. Square root it, and we get 5. So my 3 sides, right, it's this side is 4.1, this side is 2, and this side is 5. So for perimeter, we just add those up. 2 plus 4.1231 plus 5. That's 7 plus, 4.1231. You can add in either order. 7 plus 4 is 11.1231 units. So we can see that the perimeter and the area were not the same. And then in this case, we also had to find the perimeter by doing like a squared plus b squared equals c squared because the lines weren't straight. Right, on the last one, I had 2 lines, my 6 and my 8 were straight, but any diagonal line, that's key. Any diagonal line, to get the distance, you have to do a squared plus b squared equals c squared. So in this case, I had 2 diagonal lines, so I had to do a squared plus b squared equals c squared twice. Right? Now, case 3 is going to be the hardest one, okay? And that's where I have 3 diagonal lines. When all 3 of them are diagonal lines, for the area, we cannot do it easily because you can't count any of these. And if I wanted to make a 90-degree angle, right, like that height kind of would be here, I can't count that either. That's also, and we don't even know what point it's hitting at. So in order to do this, you have to do a lot of weird, nasty stuff. Don't look at the Carnegie book, please, please, please. The Carnegie book, it asks you to try to do like parallel and perpendicular equations, and it asks us to do these systems of equations that we haven't even gone over yet. Midpoints, it's like super, super complicated. Okay, I have a way that I think is much, much easier for us. And it's still hard, but it's a lot more doable. And so what I'm going to do is I'm going to just take each point and kind of extend it left and right or up and down until I can kind of make a rectangle or a square around this shape. So usually it ends up being a rectangle, sometimes it ends up being a square. But we're going to kind of just go around the shape like that. So you're just going to, essentially extend each point to make a rectangle around it. Okay, and what we're going to kind of do is, if you kind of imagine, if I had a rectangle, and if I cut out this little triangle, and if I cut out this triangle, and if I cut out this triangle, what would I be left with? I'd be left with the inside. Now, when we cut out, in math, that's subtracting. So we're going to start off with the whole, which is the area of the rectangle. And then we're going to subtract our 3 areas of our triangles. Right? And that's going to leave us with this inside area, which is what we want. So that's kind of the basis of that. Okay? So that's what we're going to be doing. So we're going to basically, I like to kind of just say, name them. To me, that's easier. So I'm going to name them as like, this guy's number 1. This guy's number 2, and this guy's number 3. So our first thing we're going to do is we're going to find the area of the rectangle. Okay. So this is over 1, 2, 3, 4, 5, 6. And then up 1, 2, 3, 4, 5, 6, 7, 8. So the area of my rectangle is base times height, 6 times 8. We get 48. And then I'm going to do each little triangle. So area of triangle 1. Okay, so 1, 2, 3, 4, 5. Let's do a different color for these triangles so we don't confuse ourselves. So starting kind of right here, up 1, 2, 3, 4, 5. That's going to be the height of that triangle. And over 1, 2, 3, 4. That's going to be the base of the triangle. So 1/2 times base times height. 4 divided by 2 is 2. 2 times 5 is 10. Remember, 1/2, if you have an even number, it's just dividing by 2. Then we'll do area of triangle 2. So here, my base is 1, 2, 3, 4, 5, 6. It's that whole base. And my height is 1, 2, 3. So I'm going to do 1/2 times the 6 times the 3. Then I can kind of cross cancel that. 3 times 3 is 9. And we'll do area of triangle 3. Okay, our height is the whole thing, 1, 2, 3, 4, 5, 6, 7, 8. And the base is 1, 2. So we'll do 1/2 times that base was 2 times that height was 8. We get 8. Okay, so how are we going to get the area of this inside piece? Like I said, what we're doing is we're taking the area of everything and we're subtracting off those 3. So the area of triangle JKL is equal to 48 minus 10 minus 9 minus 8. So you can use a calculator for that. You can also add these 3 first, like 10 plus 9 plus 8 is 27. So you do like 48 minus 27. And you get 21. Okay, so our area of triangle JKL ends up being 21 units squared. Okay. Now, this one did not ask us for perimeter, but had it asked us for perimeter, we would then need to do a squared plus b squared equals c squared. Now, we've already kind of set up these triangles. So we haven't done a squared plus b squared equals c squared, but we know we have 4 and 5. So we can do 4 squared plus 5 squared equals c squared to get that side. Then 2 squared plus 8 squared equals c squared to get that side. And 3 squared plus 6 squared equals c squared to get that side. And so then we would add up all 3 of those, kind of c's. All right, so there's that one. So just jumping over to a couple problems from the homework. We're, under 20 minutes right now. We'll just look at a few of them just to have some examples. So some of these are extremely, extremely easy. So this is section A. On section A, it asks us to find the area and the perimeter of different rectangles. Okay, if it's straight lines, vertical and horizontal, you're super, super easy. Now remember, all lines are straight. So it's not straight lines, but it's vertical and horizontal lines. You can count. So here, if I counted 1, 2, 3, 4, 5, 6, 7, our base is 7, and our height is 3. That means this guy's also 7, this guy's also 3. So for the area, it's just base times height, 7 times 3. We get 21 units squared. And here you have the units squared. Okay, that's problem 1 from your homework. And then perimeter, it asks for both perimeter and area. Okay, we're just going to add them all up. 7 plus 3 plus 7 plus 3. If you really, really want to use 2 length plus 2w, you can. But I like just not memorizing any formulas for perimeter and always just adding up all my sides because it always stays the same. You just add up all your sides. So that one, extremely easy. A little bit trickier, but honestly not too much trickier, would be if we have something, that has diagonal lines. With diagonal lines, I cannot count them. So what we have to do first is we just have to figure out the side. So I'm going to do an a squared plus b squared equals c squared. That's 2, and that's 1 to get this c. So our first step is going to be to do 1 squared plus 2 squared equals c squared. That's 1 plus 4 equals c squared, which is 5 equals c squared. And we're going to square root this. And for our homework, normally I like you to round out to 4 decimals. But for this homework, it says round your answer to the nearest hundredth. But I really do want us to round to 4 decimals until we get a final answer. Okay, so on all of our intermediate steps, I want you to round to 4 decimals. So this is going to be 2.236. It's 0.6, so 2.2361 is C. Okay. Now, I don't need to do between X and Y because I know this C will be the same. Those guys are the same. So this is also that 2.2361. They're both 2.2361. But I do need to do this side. I'm going to use another color for us. So using another color, we have a triangle here. And so this is 2, and then this is 1, 2, 3, 4. You can even call it D if you want to. You know, you can do a squared plus b squared equals d squared. Or you could call it C2. A lot of times I just call it C2. So 2 squared plus 4 squared is our second C. So second C squared. Okay, 2 squared is 4. 4 plus 16 equals our second C squared. So that's 20 is equal to our second C squared. We're going to square root both sides. Right? The reason we're square rooting both sides is to cancel out that squared. Right, and so we're going to just do the square root of 20 on a calculator. And you should end up with 4.4721. That's our second C. Okay. So now we just do our formulas. Area is base times height. So 2.2361 times 4.4721. And you just multiply those on your calculator. And so when I did that, I got, 10.0006. And it asked me to round to the nearest hundredth. So to the nearest hundredth, this is 10.00 units squared. Now be careful. It's not 10. 10.00 means that there are more decimals later. So that is kind of a little important trick. If you put 10, I'm going to give you full credit, but just be careful about that. When you have zeros after the fact, you do want to kind of put 10.00. Okay, then for our perimeter, we're just going to add up all our sides. So the first side was 2.2361. Then our next side is 4.4721. Then this next side is again repeated 2.2361 because it's a rectangle. Right, rectangles, the opposite sides are always equal. And that side is a repeat of the 4.4721. So again, you'll just type this into a calculator, and you should get 13.4164. And since we're allowed to round this to the nearest hundredth, that's 2 decimals. We'll round that to 13.42. Oops. Right, the 6 rounds up, so 13.42 units. So a little bit harder than the last example, but definitely doable. And then next up, we have section B in our skills is going to be to determine the perimeter of each triangle. And remember, anything that's a vertical or horizontal line, you can count. Anything that's a diagonal line, we'll need to do a squared plus b squared equals c squared. Now, this is only asking for perimeter. It is not asking for area. Section C will ask for area. Okay, so in this case, make sure we always check what we're counting by, right? We're counting by ones, but hypothetically, we could be counting by 2s, 4s, 6s, something else. So be careful about that. I didn't even check on this one, but luckily, yeah, we were counting by ones, and we were counting by ones. I think on most of the skills homework, it is counting by ones, but just double check that always. So this is 1, 2, 3, 4, 5, 6. Oh my gosh, 2, 4, 6, 8. Okay, so that distance is 8. Since we're doing perimeter, we don't care about the height. We just care about all 3 distances. So I'm going to call this C, and we'll turn this into a triangle. So it has a distance of 2 and then a height of 1, 2, 3, 4, 5, 6. So 2 squared plus 6 squared equals c squared. That's 4 plus 36 equals c squared. And that's the 40 equals c squared. I'm going to square root both sides because I want to get rid of this c. So you could have written 40 equals c squared first and then square rooted it. I just kind of was working ahead and knew that that's what I was going to do because I've done so many of these. So when we do the square root of 40, we get 6.3246. 6. Wow, this thing is really giving me problems today. 6.3246. All right, and then we need to do the other one. I'll use another color. So same process. It is a diagonal line. So we want to make a kind of right triangle out of this. Right, so across we have 1, 2, 3, 4, 5, 6 across. And then going down, we have 6 down. And so we'll do 6 squared a squared plus b squared equals c squared. That's 36 plus 6 equals c squared. That's the square root of 72 equals c squared, or square root of c squared, right? I'll show that 36 plus 36 is 72 equals c squared, and then you square root it because we want to cancel out. So square root of 72 you'll need to do on a calculator, and we end up with 8.4853 equals c. And so then for our perimeter, we're just going to add up all of our sides. We had 8, which was nice because we just got to count it, plus 6.3246, plus 8.4853. And you'll just type those into a calculator. And we should end up with the perimeter equals 22.8099, which we can then round to 2 decimals. That's what it asked us, 200th. So 22.81 units. Okay, so again, if you have a diagonal line, you're doing a squared plus b squared equals c squared. And if you have a horizontal line, then you're doing, or a vertical line, you're just counting. So part C is now asking for the area. Okay, some of these are very easy, and then some of them are that hard, tricky case. So the easy ones, just area, same formula always. 1/2 base times height for triangles. So 1, 2, 3, 4, 5, 6, 7, 8. And the height here, we're going to draw a straight line down. I'm not sure if this was the same triangle or not. 1, 2, 3, 4, 5, 6. So our area will just be 1/2 times 8 times 6, right? And this works because we can make a perpendicular symbol there. One is across, one is up and down. If you had a triangle, like this, you could do the same thing. But now just our height is going up and down, but our, base, you could just put across that way. So kind of base and height. Right, so if you had a triangle going up and down, it's the same thing. If you have one side that's vertical or horizontal, you can do it this way, which is easier. So 8 times 2 is 4. 4 times 6 is 24 units squared. They did not ask us for perimeter on part C, only for area on part C. And finally, this is the hard case, but we already did this problem. Okay, this is the problem that we already did, so I'm not going to redo it. But, number 4, and I think it's numbers 4 through 6, are this kind of hard case, right? So remember, the basics of this is what we want to do is we want to just create our rectangle around it. And then we have to do 1/2 base times height for this guy, 1/2 base times height for this guy, 1/2 base times height for this guy, and then do the overall base times height of the rectangle, and then we subtract off the 3 mini areas. So